The Michael J. Wargo Exploration Science Award is an annual award given to a scientist or engineer who significantly contributed to the integration of exploration and planetary science throughout their career. The 2024 Michael J. Wargo Exploration Science Award is given to Dr. Ben Greenhagen. Dr. Ben Greenhagen is a planetary scientist at the Johns Hopkins Applied Physics Laboratory. He received 2 bachelor's degrees in geology and geophysics from the University of Minnesota, a master's in earth and planetary science from WashU here in St. Louis, and a PhD in geology and planetology from the University of California in Los Angeles. He's an expert in the surface environments of airless bodies and thermal infrared instrumentation. He leads remote sensing and laboratory research investigations and instrument development efforts. He's participated in a wide range of active missions and projects, including PI of NASA's LaForge Lunar Instrument and DALI, multispectral imaging compact radiometer. He is deputy PI of NASA LRO Diviner, and the NASA PRISM Lunar Vertex missions. He was a co-I on NASA's Alcirus and Lunar Flashlight missions, and ESA's Bepi Colombo and Comet Interceptor missions, and that's just for starters. He's also done a tremendous amount in support of our community, which I'm particularly grateful for. He serves currently as the league chair, and you'll be hearing more from him tomorrow morning in that role. He's been the deputy science chair and an executive committee member at large, and he also engages the community and encourages professional and personal development at all career stages, from interns to senior staff. And I want to add my personal thanks for the support he's given to SSERVI, including for our senior review a couple of years ago throughout. So Ben, congratulations. Thank you. Yeah, this is the. We'll show it to everyone. This is the award right here. Yeah. Okay.
All right. Great. Yeah. Thank you very much. It is really an honor to receive this award. So I have my own slide like that too. I will admit, when Greg called back in May to say I'd won this award, I was a little bit in shock. It was an unexpected achievement. And at the same time, it's an award that has a little bit of a, it's kind of an old guy award. and I don't really consider myself to be an old guy. I'm 43 years old. Fortunately, if you look at this distinguished list of people, it is not entirely old guys. So it is not an old guy award. We're setting that precedent. But if you look at this list of people, those are really, really impressive resumes. And in accepting this award, I want to acknowledge that it's hard to compare oneself to those resumes. And so I'm accepting this award, not just with what I've done, but what I will do. I'm taking a debt to the community that I need to keep doing the types of things I've been doing to really, truly win this award. So thank you. So in preparing for this talk, I'm going to go a little faster because I know we're behind schedule. I reached out to some people. There's not really any guidance about how to do it, but the advice I got was give your perspective on something, and I'll give my perspective on exploration science in a few minutes. Tell a little bit about your journey, and don't talk about your cats. So I'm going to talk a little bit about my journey, but like I said, before that, Mike. So Mike, I actually knew Mike, worked with him from about 2005 through until his death in 2013. Most people know Mike because he took LROC's motto of science enables exploration, exploration enables science, and really brought forward. Basically, at every single talk he gave, he started with that slide and he ended with that slide. I also remember Mike for that, but the thing I really remember is as a graduate student working on LRO, he took a real interest in what I was doing for Diviner. He asked really good questions, and not just superficial questions, but questions that would really get at what we were trying to do and cause us to think about why we were doing things. And so it's aspirational to be able to try to ask those questions, and I'm not there. But I do try to ask questions that should be asked, and sometimes that's because maybe something hasn't been explained and there's someone in the room who could use that additional context, or maybe it's because something is not being said that should be said. So I will try to improve in that area as well. So who is Benjamin Greenhagen? I was inspired hearing Nikki Fox talk at COSPAR last week to put myself into ChatGPT and ask ChatGPT who I am. And she encourages you to do this to see what AI thinks about you and how it's inaccurate. So when I did this, I got that I'm not very important. So that's a bit humbling. If you add additional cues, it kind of makes stuff up. So if you say the planetary scientist, they add some generic information about what a planetary scientist would do. Still not very satisfying. You can continue to ask questions, and ChatGPT knew that I had worked at JPL, I was involved in LRO and LSIC, and had published publications, but it also thought I had gone to Case Western University and ASU, which I have not, and been involved in the OSIRIS-REx mission. So just be careful if you're using this to start writing your proposals and whatnot, you might want to watch out. So I have to do this the old-fashioned way. So my journey, can't have this presentation written by ChatGPT. My journey starts in Minnesota. I grew up in Minnesota. I stayed close to home, going to the University of Minnesota. If Bill Bach, he's in the room, he says he's a diehard Vikings fan, but no small part of my decision to stay in Minnesota was to maintain my Viking season tickets until I had it for 10 years, so I got the special pin. So that's another level of diehardness. Important thing that happened there is I've been told basically my entire teenage life up until college that I should be an engineer. You should be an engineer, Ben. And when I got to college, I realized very quickly that wasn't for me. There's aspects of it that I related to, but it wasn't the way I wanted to go about solving problems. And so I switched to science at Minnesota. I also met my future wife at Moraine. The next kind of big leap that happened was having an LPI summer internship in 2002 with Laurel Kirkland. This was my first big break into planetary science. And Laurel was very instrumental in allowing me to experience what real planetary science is, to develop and do field investigations, and exposed me to thermal infrared spectroscopy, which has more or less defined my career. So Laurel is very instrumental in terms of where I am right now, because without that internship, it's very likely I would have stayed in terrestrial geology. The next stop was here at WashU, working with Brad Jolliffe. Brad taught me to be a scientist. He taught me to go about problems and think about everything that you need to do to make sure that you're coming at it from every angle and are able to address what you want to do. And we did some really interesting Mars research related to spectroscopy of magnesium sulfides, including something that wasn't named at the time, but was later named meridianite. He also gave me an opportunity to work on Clementine, and I was like, no, I'm fine with this Mars stuff. I can't do this moon stuff right now. That was a missed opportunity. I had to make a personal leap to leave WashU after 2 years with a master's to go to UCLA to solve an issue that many of us have, the two-body problem. And in going there, I was expecting to work with David Page on Mars research. He's a famous, or if you believe Steve Squire's book, infamous Mars scientist. And there I did make the leap to lunar science. There was the opportunity to work on Diviner from the very beginning, to be involved in what the investigation was going to do, how it was designed, worked very closely with JPL engineers all the way through, and was also able to start getting a little bit of my voice in terms of activism, in terms of student government, and what the community was doing at the same time. Next stop was at JPL, a natural extension of that. At JPL, I started expanding beyond the moon. JPL wasn't doing a whole lot related to the moon, and so I get more involved in outer solar system, including discovery proposals, and also working on instrument proposals for JUICE and Europa Clipper. I also became a dad. So that's my daughter. It doesn't really look like a daughter in this particular picture. And there's a version of this that I posted online a long time ago where there's a fake beard put on her to match me. But yes, Madeline Cellini Greenhagen, my Maddie Moon. And then the final stop, and where I currently am, is APL. This, once again, was to solve the two-body problem, a serious problem that we face in our field. And very fortunate that APL addresses this, and they don't shy away from hiring couples if the job is appropriate. At APL, given the group of lunar scientists that had there, I doubled down on what I was doing for the moon. And it's been very successful in terms of all of the missions that I'm working on going forward, and very, very happy a couple years ago to be named the PI of La Forge, which will go to the lunar surface in 2027 or 28 or 29. We'll see. We'll see when it gets there. Also got involved in LSIC leadership. So this is an opportunity to work with Space Tech, a completely different part of NASA that's much more industry focused and working on early technologies. And I also started to find my voice at APL. I have this belief that if you want to be part of an organization, you just serve the organization. And so by being part of line management at APL, being part of the business development, gives me a little bit of that ownership. And I also took that into the community with League, starting as an at-large member, going up to be deputy science chair, and eventually chair. And there's too many people to thank at APL. Have been at APL almost as long as I was at WashU, UCLA, and JPL combined. But I would acknowledge Ben Bussey, who hired me to APL, and thank you, Ben. And also left 2 weeks after I started APL to take Mike Wargo's job at NASA headquarters. And I don't let him forget that. All right, so exploration science. So ChatGPT again, what is exploration science? It does much better job at this. Had a pretty lengthy explanation for a very simple inquiry, but I liked what it said at the end. It says, overall exploration science involves interdisciplinary research, often pushing the boundaries of technology and knowledge to gain insights into unexplored and poorly understood environments, both on Earth and in space. It's a pretty good definition. And when I was trying to break this down visually, this is what I came up with. There's kind of two axes here for exploration science. It needs to be into the unknown. It can't be something that we know too well, because then there aren't these question marks. You don't have the unknown knowns, the known unknowns, and the unknown unknowns. But exploration science is science. It should be preparation through research. And so the area that we're trying to get to is up here. And it's much easier to think about what these things mean. You can go into the unknown completely unprepared on your umbrella, or you can do something that is not unknown at all and has been very well studied, such as tourism. And then you can do what we did with Apollo. This picture was harder to figure out, but I think I managed that. So when I wrote this into bullets, this is what I came up with. So the science of exploration is the following. You collect data that directly influences exploration. These are the things that address the engineering requirements, the known knowns and the known unknowns. You also study the processes that may influence exploration. These are the unknown knowns, things that we know will impact, but we don't know the extent to which they'll impact. On the moon, this might be something like solar energetic particle events. We know they're going to happen. We are incapable of predicting them in the same way that we can predict weather on Earth. If we do the studies that are needed to be able to get that capability, that changes the way that we have to mitigate them on the moon. You also collect generally useful data, because otherwise you have no way of doing the unknown unknowns. You have to be willing to say, I'm going to collect this data not because it's answering this question I'm asking now, but it might answer a question that somebody asks in the future. You also need to document the exploration. You want to see what the effect of that exploration was on the environment, and every time you want to get a little bit better. So that's what I came up with for the science of exploration. And I was going back and thinking, is there a good example of how we've done this previously? And there's a great example. It's LRO. And I'm biased. I'm extremely biased for LRO, having worked on it since 2005. But it really is exploration science. And the whole history of it, starting with the Exploration Science Mission Directorate, or Exploration Systems Mission Directorate, and moving over to the Science Mission Directorate after a one-year mapping orbit, and then staying there, exemplifies how the instruments that were chosen by exploration at that time to collect all the data that's needed to return humans to the moon could also address all these other science questions. And there was a lot of talking back and forth between those groups at that time to make sure that this would happen. And not only has it done a really good job on that science side, it did well in its science mission, its extended science mission, the extended science mission 2, 3, 4, 5, and we're preparing for extended science mission 6. And I don't think SMD quite realized they were signing up for that at the time, but we're very grateful for that support. Then there's the harder part. What's the next great exploration science mission? I think it's Viper. And if I was giving this talk a week and a half ago, I think I would be saying very different things. We talk a lot about the science for Viper because it is an SMD. And we all know that it would collect exceptional science measurements. But what we continue to overlook is that it's more than that. It also collects data that directly influences exploration. Even if it's not needed right now for those engineering requirements, it still influences, it still addresses things that would help us explore the moon. And it also is an ISRU technology development demonstration as well. So you have a mission here that's addressing SMD, ESDMD, and STMD. And that appears to be the problem, that it has too many customers. And I don't think that should be its fault. So I know there was the discussion yesterday, and this community asked fantastic questions. And I'm sure if Mike Wargo was here, he would be asking fantastic questions. And I have questions too, that I don't think we really have fully gotten the answers to yet. Yeah, decide how far I want to go that way. So one question is, CLIPS is risky. It's risky in terms of actually being delivered. It's risky in terms of schedule. As far as I'm aware, every payload that we intended to land on CLIPS has been delayed and had their development delayed in order to accommodate a late delivery to landers, or has been delivered to storage because of that. But Viper didn't get that opportunity. It's getting terminated and dismantled very quickly, very suddenly. And so that's one question. Why is that? Another question is, we've heard over and over from our science leadership in the past year or so that it is the priority to focus on the missions that have been confirmed. We don't get New Frontiers until 2026. We don't get Discovery until 2026, or Simplex till 2026, because we were told we're pushing off decadal objectives, we're pushing off all those science teams and all those efforts because we need to concentrate on things that have been confirmed. And Viper was confirmed, and I don't understand that either. So we have lots of questions, and hopefully we'll continue to seek those answers. The cupboard is not bare. There's a lot of things going to the moon. And the final point I want to make is that, are we actually embracing exploration science still? You can see there's a lot of colors on here that are separate for human exploration science and space technology. Are we working together so that each of those opportunities is advancing exploration science, or are we advancing exploration, advancing science, and advancing technology? Because it's a lot faster to build up those silos than it will be to tear them down, and we need to be mindful of that. Science enables exploration, and exploration enables science. So in closing, ask the questions that should be asked, seek opportunities, and don't be afraid to reinvent yourself. Lunar exploration requires a lunar community. It's a big tent. It's not just people outside NASA, it's people inside NASA as well. And we need to be working together as a community. And thank you. Thank you to the people that have supported me throughout my career and the people that will support me in the future as well.